So the last lecture we have completed the particular introduction of OR, how that operation research is evolved during the World War II. That part we have seen. Then uh, the application of ORs in different sectors like uh, budget, hospitals, that you can call it as the plane stations or banking, is it right? Airport, any many locations we have gone through this. The discussion is over. But how these models or how this war is has applied on the different parts or different war has having different applications. So how it is there, or for that, if you look at the airport system may be different, bank system may be different, hospital system may be different, years planning or something, uh, budgetary things, these are different. So their main aim is different. If you look at the hospital, the main aim is that to give the service to the patients, is it right, some emergency, etc. Banking, if you look at the banking side, there the need is different. Peoples are coming, that withdrawing money or depositing money, their need is different. Airport, planes are coming, peoples are coming, so each person has to sit on the particular plane, and so different things are there. Budgetary things, national budget, etc. Their things are different. There no one is coming, no one is sitting. But still OR models are applicable in many applications. Defense application may be there, farmers, agriculture applications may be there. How it is possible? So how this particular subject, this particular subject is having wide variety of applications because of these particular models. So here our today's topic is classification of model. What is meant by classification of model? So here I have written only one line here. Depending upon structure, then depending upon purpose, nature of environment, behavior, etc. So based on such a different points, we can classify the OR models. So what is meant by actually OR model? What do you mean by actually OR model? So whatever the descriptive part is there, that descriptive part should be converted into mathematical problem. That is nothing but the OR model. The descriptive part, descriptive information should be converted into mathematical form. That is in some x, y, z, whatever variables you are choosing, greater than, lesser than, etc., equal to. Is it right? Then based on that we can develop the mathematical problem, and when we solve that mathematical problem for that variables x, y, whatever will be unknowns, then we get the solution. So this is called the OR model. Mostly what all the models are there, what are depending upon structure, depending upon purpose, depending upon nature of environment, behavior, etc. Whatever these all models are there, these all models are mainly designed for two purposes. In industry point of view, hospital point of view, airport point of view, any point of view, if you look at, these all models are basically, or their main aim is same, that is increase the benefit, increase the profit, first condition, and second condition is that reduction of cost. What are the operating cost is there, that operating cost should be reduced, and what are the profit margin is there to that particular organization, to that particular entity, that should be increased. Profit increase and cost reduction. These two are the I can say basic concept or basic object of the model. Increase the profit, reduction in the operating cost or cost. So today we are looking to take view on this all the models. So what is these models are there, how these are different, and how we can understand these models, and based on that models how we can go for the particular problem definition or problem formulation. Once we understand how the problem is formed, then the next step is how to solve that particular problem. Is it right? Right now we are not having problem, we are not having solution. As problem is not there, no solution will be there. Is it right? Without problem, there is no solution. So as we are not having the problem, where is the question about solution? Then first we have to develop the particular problem. Then for that development of problem, we have to collect the information, and we have to put that information into different points. Okay, so whatever information we are collecting, we must know whether it is which type of model is there. Model means which type of problem it may be formed. So that is our first today's part. So that's why we have taken the today's topic, classification of model. So in this, the first part is there by structure. Okay, by structure. So by structure, what type of models are there? So here three models are in front of you. Okay, first one is the iconic model, second one is the analog model, and third one is the symbolic or mathematical model. Symbolic or mathematical model. So how these particular models are working? So iconic model, what is meant by iconic model? All of we are knowing prototypes. Is it right? How many of you are taking the part in the project exhibitions or model preparation? Have you taken part into such events, model preparation, etc.? Anyone reply? Anyone? Can you reply me? Gaurav, Shubham, Rishikesh. Can you reply me? Have you taken the part into such events? Rahul, Sadashiv. Anyone reply me faster? Model preparation, model exhibition. Such events are there. Have you taken the part into such events? Anyone please reply me? Okay. So as 2 years pandemic is there, you are might be taken into the part. But here in this particular event, what we are doing, we are asking to students to represent the different models. Okay, so some students may preparing a small lathe machine model, then drilling machine model, piston and cylinder arrangement. So this particular, what are this here iconic model is there. So it is what is that? That is the scaled version of actual object. So whatever the actual object is there, it is of large size. So same object but of smaller scale we should require to prepare. Like here it is written IC engine model, boiler model, etc. Okay, so IC engine model. So this is the cut section of piston and cylinder arrangement. So this is the particular cylinder in which piston is there. When you rotate this hand, piston is moving up and down. So this is the model which tells you that how this particular piston and cylinder arrangement works in engine. Is it right? So IC engine models, boiler models may be there, machine models may be there. In previous, before introducing this AutoCAD, CATIA to the particular mechanical industries, Previously in company, if they prepare new cars or two-wheelers, etc., they are preparing small models of these cars, or we can call it as two-wheelers. It may be from wood, wax, etc. Soft particular things may be there. Obviously, they are producing that particular model. They are checking the models, how it look like, what feel it gives. And nowadays, with the help of CATIA, AutoCAD, and ANSYS, we are preparing the model on the computers. We are probably giving some testings on that. Is it right? So this is one kind of model, that iconic model. Why the name is given iconic model? Because whatever the big object is there, that big object is converted into small model. Many a time in our house, some models are there. Some we can call it as the ship model is there, or small aeroplane model is there. We are using them for playing the kids, etc. But these are actually models which are produced. How that particular plane or ship look like, is it right? So that is the called the iconic model. So nowadays, these iconic models are the trend of forming the iconic models is a little bit less because of the computer work. We can prepare the 3D models on the computer, and we can test them on the computer itself by softwares. There is no need of preparation of actual model, but still actual models are prepared. Similarly, if you go into the some of the organizations, you will find the building plan in glass box. That building is used to show the model how that building will look like, or where what sections will be there. Is it right? I think you have seen that particular part also, that building sections and building models, etc. So these are called the iconic models, where the from actual model, the small icons will prepare. Then analogous model. What do you mean by analogous model? One set of properties are used to represent another set of the properties. One set of properties are used to represent another set of properties. So here we are not required to test all the particular things. Just by looking at one set of properties, we are representing the another set of properties. For example, water by color. So how you can say water by color? Let's say dark color water is there, green color water is there, the blue color water is there, and white color water is there. So hereby, by looking at these particular colors only, we can understand the whatever the white color water is there, it is from the some filtered water is there. Yeah, little bit bluish color water is there, it is natural water will be there. Green color water means it may be from pond, or where some we can call it as the in Marathi we can call it as shewal. So like that, that color water may be there. Dark brown or dark black color water is there. That is the waste water. Is it right? So by looking at such type of water, that means here to understand the different types of waters from where it is collected. Let's say dark color water, it is collected from some um, um, west side. Green color water is collected from the stored ponds or some lake, etc. Blue color water is the river water, which is flowing water, or natural water, maybe there mountain side. It is again pure water. White color water is from some, we can call it as the filtered water. So by looking at that color of the water, we can understand what property it is having, that purity, that property, water purity, then source of collection, then whether it is drinkable or not. Is right? So different things, different other properties we can understand by the only one point, by studying one thing, that is color of the water. So this is called analogous model. Based on that particular one property, we are comparing the other property analogous to that. Is it right? analogous to that particular one property. We are just measuring the other properties, or we are representing the other property. This is called analogous model. Then symbolic model. What do you mean by symbolic model? Symbolic or mathematical model? Mathematical models, it is also called as symbolic model because many symbols we are using in the mathematical models. We are using many symbols in mathematical model. So here one equation is written: sigma is equal to E into epsilon or strain. Is it right? Here in this particular condition, sigma represents, can anybody tell me, sigma represents, anyone please reply faster? Anil, Sujit, Sadashiv, Rishikesh. Please give me answer fast. Pramod. Sigma represents, Pramod, Rishikesh, stress. Yes, correct. E represents, sigma represents stress. E represent. Please give me answer fast. Unmute yourself. Gaurav, Pramod, Sadashiv, Shubham, Rishikesh. Anyone please reply me fast. Elastic limit, or if okay, E represent elastic limit, and the last one, epsilon represent strain. Is it right? So whatever your mom subject was there in second year, in that you might have studied this. Sigma is equal to E into epsilon. Is it right? So this is the particular one mathematical model. So here variables of problems are represented by the mathematical symbols like stress by sigma. So universally it is accepted that stress is represented by the sigma. Is it right? Stress is represented by sigma, and whatever we have to uh, whatever we have to particular represent here, sigma, that is stress, epsilon elastic limit, and E elastic limit, and epsilon strain. So that particular part is constant, that is universal. And here what relation is shown here? Here the relation between sigma and epsilon is shown here. Otherwise, most of the time what is there? The most of the time in this particular model, the particular sigma is equal to, sigma is directly proportional to this strain. To make it equal, we are using E. Is it right? So like this, the particular symbols are used in this particular mathematical model. So our aim is also there. So we have to understand which model is this. This is which model and how we can use this particular model. Is it right? So that we have to understand first. And then we have to convert this model into mathematical form. Okay, then so these models are by structure. These all models are by structure. The next point is by purpose. So in purpose there are different models: descriptive, predictive, and prescriptive. What do you mean by descriptive models? Descriptive models is nothing but it explains certain aspect of problem or situations. No any full details. For example, survey, questionnaires. Okay, so these are called descriptive models. Means here we are taking lot of data, and after analyzing that data, we will be able to calculate the particular conclusions. That is called descriptive model. Means explain certain aspect of problem or situation. So right now, if I asked you, I am having problem of or there is a problem in the group of people, that which phone should be used or which phone is better. Let's take an example of Samsung and Vivo, or Samsung and Redmi, etc. Any type of phones category you can take, and just you have to make the comparison which is better according to the people, so not according to your own individuals. Okay, so what you will do, you will make the questionnaire, that what is the Samsung performance, what is the Redmi performance, what is the Vivo's performance. Based on that performance, you will put the questionnaires. In performance under, you will put the questionnaires like life of battery, charging time, then applications, hanging, is it right? Easiness, uh, that what are the touch screen, quality of the touch screen, different, is it right? Then weight, then power of conditions, camera, different questionnaires you are putting, or you are going for survey. You will ask different people, what is your phone, what, how it is performance. So like this, you are asking the people's different questions, or you are taking feedback from different peoples, and you are collecting that data. But based on that data, when you compile that data and make the analysis, you'll find that no any full details will be there. Here you are not writing any kind of details, that what is the gigahertz, what is the speed and RAM, and chip is there, what type of Android version is there. So that details will not be there. Here the outlook details are important, like weight, handling, functionality, then battery, then you, we can call it as the uh, camera, is it right? So like this, the things we are collecting. This is called a survey model or questionnaire model. So here, whatever the data is there, that data has been collected with the help of questionnaires from the surveys, and then analysis has been made, and then model has been developed. So let's say two mobiles are there, that Samsung and Redmi, and you have gone through survey of 1,000 people, and from 1,000 people you got that like that 600 people are preferring Samsung, and 400 people are preferring Redmi. So like your conclusion may be there. So what your descriptive model says, that nearly for 60% people are happy with Samsung phones, and 40% are people are saying they are using Redmi phones, and their satisfaction level. And so you are making some 1 tera, 2 tera based on this. So our question was simple: which mobile phone is better? But for that, you have to require to go for many more work. You have to prepare the questionnaire, you are required to go for survey, you have to record the people's opinion, and you require to prepare the then final outcome, what will be the actual thing, and then you are coming to the descriptive point. So this is the fact, and this. Okay, this is called the descriptive model. Then predictive model. So predictive model means what? Based on the data collected, can predict the approximate result. So here, for example, score after exam. So we are very expert in this as a student point of view. We are writing the papers, and when we come out from the exam hall, we are starting chit chatting with our friends. What is the answer of this particular question? What is the answer of this problem? My answer is this, your answer is this. Is it right? So if your answer, my answer is correct, I will get 4 out of 4. You will get 3 out of 3. So we are making the correction. So I have just solved 50 marks paper, so I will get 40 marks. I have completed 60 marks paper, I will get 52, 55 marks. So here I have written this much example. So out of 3, at least examiner will give 2, etc. Is it right? So these predictions we are making. Similarly, so this is one example. Score after exam. Let's take another exam. Predictive model. So your you might be knowing that your father or your elder brother may be there. They have taken the life insurance policies, etc. That the life insurance policies, they are asking what is your age right now, what is your income, how many persons are depending on you. Is it right? So like this, that means they are collecting the data. Based on that data, they can predict. Yes, then you have to take this policy and you have to make this much of premium. You can pay this much of premium per year, per 6 months, quarterly. So like this, the things are there. So that is called predictive model. Or another model is there. Again, if I want to give the example, there are pension schemes in the market. You might be not knowing that particular part, but your father or your elder brother, those who are on the service side, they are knowing. So what is today's income, today's earning? So how much pension you want after 30 years or after 20 years of your service? Is it right? Then you have to pay premium of this much up today. Then you will get 50,000 as a pension after 60, age of 60, or 30,000 as age of 60. So whatever that pension calculators are there, or we can call it as the particular score after exam, LIC calculators are there, premium policy calculators are there. So all these are the, we can call it as the predictive models. So here, based on certain formulas, today's age, today's income, number of people. So like this, based on certain calculations, they are uh, predicting the things. That means if you want to this much pension, this much thing, then you will get this much today's premium. You have to pay this much premium, etc. Similarly, after exam, we are calculating. I have solved this particular problem. I got this many marks, or I will get this many marks in this particular problem, and this is my answer. So like this is the predictive model. The descriptive model is different. Predictive model is different. Then prospective model. If predictive model is successful, then course of action can be prescribed. Okay. So if predictive model is successful, that means after exam, whatever prediction you have made. So let's say you have made that out of 60 or out of 70, I will get 58 marks. This is your prediction. But after actual results declaring, if you are getting 58, 59 or 57, 56 mark, near to that what are your predictions, then you can prescribe the things. That means you have to, and you can make the details work on that particular thing. Yes, I have written this much answer, that's why here 2 marks may be given, this answer may be wrong, this problem may be wrong. So that particular prescription or prescriptive thing should be happen once your predictive model is successful. If predictive model is not successful, that means if you defined that I will get 58 marks out of 70, but only you are getting 28 or 30 marks. In that case, your predictive model is going to fail and your prospective model is not going to be work there. So how you can prescribe the things? How you can define the things in the, when the marks whatever you have predicted, that marks you are not getting. Is it right? So these are the different model by the purpose, for which purpose we are using. Descriptive model used for define the things, elaborate the things. Predictive model is used for predicting the things, and prescriptive model, that is a further part of predictive model. Again, it will helpful, it will tells us how my predictions are correct, how I have used this technique to predict this thing, etc. Okay, so these are the models by purpose. Then models by nature of environment. Okay, deterministic and probabilistic. So deterministic model, assumption of complete certainty about variables and resources. Okay, so assumption of complete certainty about variables and resources. For example, linear programming model, what we are going to study. And second one is the probabilistic. Variables value can't predicted, risk consideration. For example, LIC. So already LIC life insurance we have taken into the predictive model also. So one model can be the part of two different purpose also, or by two different classification also. So predictive model is also, we can call it as the probabilistic model by nature of environment. Why? So here in these two models, deterministic model and probabilistic model, what is the main difference is there? Main difference is there, that main difference is just here, that risk considerations. Risk consideration, that is nothing but we can call it as the, here one word is coming, certainty, and risk consideration is uncertainty. We can call it as the uncertainty. Okay, so what is meant by uncertainty? What is happening tomorrow we are not knowing, so that is called uncertainty. And what is meant by certainty? We are knowing what is happening, that is called certainty. This risk consideration is come under uncertainty, and the first model come under certainty. Certainty means what? Assumption of complete certainty about variables, resources. That means in industry, if what is you are doing in industry, let's take example. In industry, the production is going on. Is it right? The production is going on. Then you require to transport that goods from one location to another location. You have to transport the goods from one location. Let's say, I will say here, let's A location is there, and from A location, I have to transport the goods to this B location, then C location, and again further D location. Is it right? So here I have to select the LPP model. In LPP again there are different models are there. So assignment problems might be Motes has taken 2 to 3 lectures about that, and transportation problem. So transportation model is again LPP. So here I am knowing I have to travel from A to B to C to D. So locations I am knowing. Certain things are there. A to B I have to travel. Then I have to just consider about variables and resources. So variables means what, and resources means what. Is it right? So variable distance, whether I should travel from A to B first, or A to C first, or A to D first. So how much distance is there in between from A point to C point, A point to B point, A point to D point? So that we can call it as a variables. Then from this A capacity, how much part of that A, let's say A can go for 100 tons of goods or 10 tons of goods. A can it can travel with 10 tons of goods. So that 10 tons of goods, it can travel at a same time. Is it right? So out of that 10 tons goods, okay, so 10 ton good is there. So this is a 10 ton. So out of 10 ton, if B required 4 ton, C required 9 ton, and D required, let's say, 2 ton. So how A should complete the particular transportation? Whether A should go to the C directly, he will give him 1 ton, then whether he should come back, or that he should go to the D, he will give 1 ton, again he should come back. So how that particular arrangement should be there? Is it right? How that arrangement or how that particular transportation point should be completed. Okay, so that is called deterministic model. You are knowing from A to B, you have to go for 50 kilometers. For A to C, you have to go for 40 kilometers. From A to D, you have to go to 70 kilometers. Whatever may be. Distance you are knowing, destinations you are knowing, capacity of A you are knowing, what requirement of B is there, it is knowing, because A is the factory location. From A, you have to transport the goods to B point, or you have to transport the goods to the C point. So that distance you are knowing, what is the requirement of C knowing, what is the capacity of that truck which is sending from A, that is knowing. So everything is knowing. But here we are developing the model for reduction in cost. That means assumption of complete certainty is there. We are knowing most of the things, and based on that most of the known part of the things, we are preparing the models. So here we are preparing the models for trucks which are moving from the A, whether it should be reached to the B first, whether it should be reached to the C first, whether it should be reached to the D first, or he should go to the C and then go to the D, or then go to the B, or what should be the truck journey? What should be the, in short, what will be the truck journey? That model we are going to form here. That is called deterministic model. And in deterministic model, whatever the errors are there, these errors are very, very less, because everything we are knowing. But if you go to the probabilistic model, here variables value can't be predicted. Risk consideration is there. So that's why example is given LIC. Whenever we are taking the life insurance, they are asking us risk consideration, risk cover you should take, accidental risk, date risk, because we are not knowing what is happening tomorrow. This is the uncertainty model, probabilistic model. If you take new vehicles also, then vehicle insurance is also there. Is it right? Two-wheeler or four-wheeler, vehicle insurance is also there. Why vehicle insurance we are taking? Why vehicle insurance? Can anybody unmute and tell me? Shubham? Shubham, can you unmute? Pramod, can you unmute yourself? Make it fast. Pramod or Shubham or both, please unmute. Please unmute.
Yes, sir.
So you are taking the two-wheeler insurance, is it right?
Yes, sir.
Why?
Because, sir, in some accidental case, we get its price or insurance.
Yeah, but some many cases you have paid the insurance insurance amount for 1 year. Is it right?
Yes, sir.
But within that 1 year, if let's say accident will not be there, then that premium will be, refunded to you, or it is just once time it is paid?
No, sir, not refunded.
Not refunded. Is it right? Still you are taking the insurance, accident, that vehicle insurance every year. Pramod, what is my question? That premium is not refunded to you, still you are taking the accidental insurance every year.
Yes, sir.
Why?
Because in some accidental case, they get refunded.
Yeah, that is meant. What I want to say here, if whatever amount we have paid every year, that is we are not getting refunded, still we are getting, means we are getting the particular insurance every year. Why? We are purchasing that insurance everywhere. Why? Because for which condition we are taking this particular insurance, that is accidental condition, it is unpredicted. When that accident takes place, we are not predict anything. We cannot predict that Today is the 27th. On 29th of December 2021, on 1 o'clock, the accident will happen. We cannot predict that such thing. So here, in such a condition, probabilistic model, the risk consideration is become important. Here the risk consideration become important, and based on that risk consideration, we have to select the model. Same LIC model, if we look at, it can be shown in the first condition also, predictive model. So here what is written, based on the data collected, can predict the approximate results. Means here we can, or here in probabilistic model, again risk consideration is there. So what data collected in the first predictive model? Your age, your particular um, income, your dependent person. So that all data is collected, and then the per year premium has been decided. And in that per year premium, the risk cover is again added, accidental risk, etc. So by combination of this thing, our LIC premium has been secured. So this is called the predictive model. This is called the prescribed model, probabilistic model. So do you understand? For most of the time, each and every models, for such a conditions, we are using the OR model. So these are basically OR models. These are called the probabilistic models. These are probabilistic models. Is it right? So probabilistic models gives us the conditions or value about uncertainty, risk. Okay, in financial point of view, if you consider this risk, then there are 2-3 methods are there. So let's consider you are having 1 lakh rupees right now. If somebody want to invest this 1 lakh rupees, one person will put into the banks on the fixed deposit. He will get secured 5%, 6% return on that 1 lakh rupees per year. Another person will put that 1 lakh rupees into the mutual funds. He will get secured 9 or 10% return on every year. But third person, he will take that 1 lakh rupees, he will directly invest into the share market. He will make the tradings every day, and he will earn more than 20% per year. But if you look at the risk point of view, the bank side risk is very less, mutual fund risk is moderate, and third side, when direct investment in the share market, the risk is more. Loss of money chance will be more. The first person will securely get 1,05,000 or 1,06,000 after 1 year. What are the middle person is there who has invested in mutual fund, because mutual funds are also depending upon share market. So he will get at least 7,000-8,000 or sometimes 11,000-12,000 such. But what are the third person is there? He can make 1 lakh rupees to 1.20 lakhs. That means 1,20,000, 1,30,000 also, or he can convert that 1 lakh into 50,000 also after 1 year. Because when direct share market relation is there, there is a risk consideration. So this is the point of view regarding your financial investment. LIC model or previously conditions accidents we are considering, that is your related to your health, your life considerations. So what are these models are there? Descriptive, deterministic, probabilistic. These all models are used for many points, many ways in day-to-day life, in government sector, in hospital, private sector, banks, etc. Okay, so this is the nature of the model by environment. The next one is the by behavior. The behavior means static model, dynamic model. So meaning of static is the stationary, and dynamic is nothing but movable model. So all the values are independent of time. and value variables goes on changing with time and environment. So here whatever I have given the such example right now, it is very fit in these two conditions, static model and dynamic model. Let's take the example of financial condition, 1 lakh rupees. So let's say I have invested this 1 lakh rupees, 100, 10,000, 10,000, and this is the last 1 lakh rupees. If I go to the bank, okay, so bank, I will get 5 to 6%. Let's say 5% I have written. And somebody goes to share market. I'll just write down here SM, share market. So he will get 10% or he will get 30%. So this particular, whatever this 5% is there with bank, we can call it as the static model. Values are independent of time. But share market, you will get 10% return or 30% return because share prices are changing daily. These are dynamic models. That particular thing, variables are going to be changed. Okay, so with the help of time, as time increases, if your values are increasing, if your things are changing, it is called as dynamic model. If with the help of time nothing is going to be changed, it is called the static model. Is it right? So by behavior, how whether time is again important factor because time is not remain constant. Is it right? Time is always going to be changed. So with the help of this change in the time, whether the whatever the variables are there in the model, whether these are going to be changed or not. If the variables are going to be changed, definitely it is having the impact on the output. If these variables are not going to be changed, then it is not having the impact on the particular output. So by looking at this particular point, the models again decided. So static model. So what are the example we have taken? That particular LIC, whether LIC premium, already we are knowing predictive model, in probabilistic model. In from first side, if you look at from, let's go to the from first point by structure. LIC is the mathematical model. From second point, it is the predictive model. From third point, it is the probabilistic model. And from fourth point, whether LIC is the static model or dynamic model. Make it fast, give me answer. We have to finish this point. Pramod, which is the probabilistic model? Sorry, LIC model, whether it is static or dynamic. Shubham, Rishikesh, Rahul, Pramod, make it fast.
Yes, sir.
LIC, what are the example we have taken? LIC premium, whether it is static model or dynamic model.
No, sir. Due to network problem, I don't get your point.
So static model, which is not having any effect of time, independent of time, and dynamic models where effect of time is there. So LIC model is the dynamic model or static model?
Dynamic model, sir.
Why?
Because the effect of time is there, sir.
How the time effect is there?
Because sir, if we apply LIC model, they ask a question which what's your age, then many questions are there.
Yeah. So that means with the help of time, the model LIC model works. Is it right? What is today you have paid the premium, next year that premium might be increased a little bit small way, but that compound interesting and other things are included. That's why at the end of that particular model, you will get huge money. Okay, so static model and dynamic model, that is nothing but which are changing with time, which are changing with the age, environment. Okay, so these are the different classification of the model, and from that we have to select the proper model for our proper particular example. Example means what? The information is provided to us, and from that information, we have to prepare the first our model. We have to first prepare our model. Then last one is the simulation, solution, analytical model or simulation model, solved by the application of mathematical techniques. If you are using mathematics analysis, it is called analytical model. Simulation techniques, if mathematical structure can be solved by mathematical techniques, required experimental analysis or some computer help, so simulation techniques. Is it right? So LIC model, etc., what we have just considered, these are analytical models. Simulation models are nothing but your body checkup, your then some computer experiments, some vehicle simulations, etc. So these are called the simulation models. So here at last, if I go for, so these many models we have to, means previously we are going to be learn in the particular OR subject. Distribution model, that is transportation model. Inventory model, how to make the inventory in our house or in our factory. Waiting time or queuing model. So in banks, whenever you are going, most of the time two counters are there. One is for withdrawal and one is for deposit. But after 2 to 3 years, you will find that withdrawal counters are increased. 2 withdrawal counters are there and deposit counter is 1, or 2 deposit counters and 2 withdrawal counters. So here waiting line or waiting time. So when a person is coming in the queue, what is the length of queue? How many persons are standing in queue? What is the average time? What is the average time of persons to stand in queue? So that calculation is used. So most of the time this waiting time or queuing model is used for railway stations when you go for ticket booking, then banks where the queue is there, airports. Is it right? So where the queue is required or queue is there, that particular location, this queuing model or waiting time model is used. Network problem. So our whatever the next chapter is there, last 6 number chapter, CPM and PERT. In that we will go for this network model. This is in your syllabus. Simulation models. So Monte Carlo simulation is there, or some analytical ANSYS software or AutoCAD, CATIA simulations are there. So how these are predicted, how these are developed. So 1 to case studies are there. Job sequencing model. The job sequencing model is nothing but sequencing which operation should be prepared first. Okay, so in industry, machine should not be remain empty. Machine should not be remain ideal. Every time that machine should require certain work. So which job is given to which machine, so that that machine is continuously work for 8 hours. So that is called the job sequencing model. Replacement model, when the machine should be replaced. Is it right? So maintenance, what is the maintenance actual expenditure? What is his own investment? At what price we have purchased that machine, for how many years that machine has worked, then what is the maintenance cost of that machine. So when that maintenance cost is increased up to certain level, the machine is required to replace. So that is called replacement model. It is not like that last year we have purchased our machine and this year we have to replace it. So that is called replacement model. And last one is the game theory. The game theory is nothing but we are playing the cards, 52 cards we are playing. In Marathi we can call it as patte. So that game theory is used for many more simple. It is derived from that we can call it as the cards theory. 52 पत्ते जे आपण खेळतो सुट्टीमध्ये, त्या पत्त्याच्या ह्याच्यावरनं गेम थेरी डेव्हलप झालेली आहे. But that game theory can be used for many more big problems also. That aviation problems may be there, companies, two companies, we can call it as the fights may be there. Is it right? So many more times we are just using these different types of models. So this is the today's point.